Hello everyone, I welcome you all to today's session wherein we will be discussing a particular concept from the numbers topic. So, the concept that I have for you for discussion today is the concept of IGP, which is part of the numbers topic. So, there will be a series of videos on the numbers itself, right, that will be covering over the next few days, few weeks, right. Every video will be touching upon a few topics together. This video is particularly about the concept of IGP. Before that, we shall also be looking at successive division. Now, since the videos are going to be brief, a basic understanding from your end would be required so as to follow the questions that we will be discussing here, the solution, the approach that we will be discussing, sharing here, right. For more detailed discussion or understanding, please visit the nearest time center that you have, right, that you have in your city. Get enrolled for the course, right, particularly if you are looking for the next year, that is this particular year's CAT, right, CAT 25, because the time is really short if you look at it. Of course, when you look at it, it's many months to go, but CAT requires dedicated preparation, right, properly planned preparation, and hence this time would also for some of you might fall short. So, please take the action at the earliest. Let us get started with the video for today. So, today we have, as I said, numbers, and particularly we will be covering the concept of IGP, index of the greatest power. So, we will start the class by understanding what do you mean by index of the greatest power, right. Parallelly, we will try to have discussion of successive division, then we will again go back to IGP. Let us try to understand what do we mean by index of greatest power, simply called IGP, Now, what do we mean by IGP or index of greatest power is, for example, let us say if I take a number like 36. So, what will be IGP of 2 in 36? Let us say, is this the question. What is IGP of 2, the number 2 in 36? So, what it means is, when you factorize 36, so 36 can be factorized as 6 into 6. 6 can further be factorized as 2 into 3 into 2 into 3 whole square, which eventually becomes 2 square into 3 square. So, 36 is nothing but 2 square into 3 square, the prime factorized form of 36. Now, in this prime factorized form, what is the number of 2's that we have, or rather, what is the index or power of 2 that we have? So, as you see here, the power is 2, and hence IGP of 2 in 36 will be equal to 2, my answer. Similarly, what is IGP of 3 in 36? So, that is also going to be 2 only, as you see. So, this is what IGP basically means. IGP means when you prime factorize the given number, what is the power that we get for the required asked number. For example, if I want to find IGP of 2 in say 10 factorial. Now, by the way, what do we mean by 10 factorial? 10 factorial basically means product of first 10 natural numbers. So, 10 factorial will be nothing but 1 into 2 into into 10. That is what it means, right. Now, when you prime factorize this 10 factorial, after the prime factorization, what is going to be the power of 2 we are asking, that is what is IGP. So, IGP plain and simple understanding is you prime factorize a given number, and in that you search for the power of the required number. For example, right now the required number is 2, I want IGP of 2, you search for the power of 2. So, how do we do that? So, for example, let us count the number of 2's here manually. So, I see there is 1 2 here, 1 2 here, there is 1 2 here also, or rather 2 actually, because 4 is 2 square, there is 1 2 here, there are 3 2's here, 2 cube because 8 is 2 cube, and there is 1 2 here. So, overall how many 2's are there? So, it is 1 2 3 4 and 3 7 and 8. So, thus we can say IGP of 2 in 10 factorial is going to be 8. So, this way, as we have solved for 10 factorial, we could also proceed with 20 factorial also, IGP of 2 in 20 factorial, IGP of 5 in, let's say, 100 factorial. We can of course proceed like this, but is it an efficient approach? So maybe not, because for writing 100 factorial like this, you will need quite a lot of space and time, right? You will need a lot of time also. Thus of course, this is not the appropriate way of getting to the answer in case of IGP. So how do we do it? So how can we do it is, observe, let's try to understand the inherent logic in this process of counting, right? What is the logic here? Observe, I will again write down 10 factorial. Okay, 10 factorial. Now since we are finding IGP of 2 here, let's count the number of 2's first. So what will be number of 2's? So please note, I am only counting 2's, not 4's or 8's. So how many 2's will be there? I will find 1, 2 here. I will find 1, 2 here. So basically every second number will be having a 2, right? So 6 will also be having a 2 in here. 8 will also have a 2. 10 will also have a 2. There is no 12th, I will stop. Next. Besides 2's, there will be some extra 2's in every 4, right? Because 4 is 2 square. So every fourth number from 4 onwards will have 1 extra 2. So I will have 1 extra 2 here. I will have 1 extra 2 here. That's it. There is no 12th, I need not move forward. Similarly, every 8 will have 3 2's, and starting from 8, every 8th number will have 3 2's in it. So 8 will have 3 2's in it, 1, 2, 3 2's, and the next will be 16, which is of course not there. We'll stop here. So please see how we are counting the overall 8 that we got here, the answer. So overall simple 2's are 5 in number, then 2's which are hidden in 4's are 2 in number, and 2's which are hidden in 8, the extra 2's which are hidden in 8 is 1 in number. So thus my answer will be 5 2's here, 2 2's here in this layer, and 1 2 here. So 5 plus 2 plus 1, my answer ends up being 8. So if we follow this process of finding out the number of 2's manually, we can actually come down to the following concept. Observe this concept once. The concept is of successive division. So what do you mean by successive division, and how is it helpful in this concept of IGP? Let's try to understand. So under successive division, what happens is, if you take a number, let's say 420 for example, if you want to successively divide it by, let's say 6, then by a 5, 6, then by a 3, and then maybe by a 5. So 6, then by a 3, and then maybe by a 5. These are the divisors that we are intending to divide 420 with. What will be the corresponding remainders? Let's check. This is a case of successive division. So how do we apply successive division? It's slightly different from our regular division, because please understand, regular division is just one process. You will have one dividend, one divisor, corresponding quotient, corresponding remainder. Here you have 3 divisors. So how do we deal with multiple divisors here? Observe. So we divide 420 by 6 first. So 6 will go 70 times. My remainder is 0. So here the remainder happens to be 0, I write. Then for the next step of division, my divisor is 3. Now the question is, what is my dividend? Dividend was 420 earlier. Now please understand that 420 now has reduced to 70. So that reduced number will be my new dividend. So that quotient of the previous division is going to be dividend of the next step. Previous division step quotient will be the dividend of the next division step. So 70 will go how many times? It will go 23 times. 1 is a remainder. So you get 1 as remainder here. Next, whatever is a quotient here will become my dividend in the third step. And third step, my divisor is 5. So 5 will go how many times? 4 times, 20. The remainder happens to be 3. So here we get the remainder as 3. So thus, in this successive division process, when I divide 420 by 6, then 3, then 5, my corresponding remainders will be 0, 1, 3 respectively. So this is a process of successive division. Now what happens in a successive division? In successive division, whatever is a quotient in the first step will become my dividend in the next. Whatever is my quotient in the second step will become my dividend in the third, and so on and so forth. Okay, I hope we are clear with the concept of successive division. Now let's understand how can we use that in order to answer this question on IGP. Observe, I want to find IGP of 2 in 10 factorial. So what I suggest here is, please note, go on dividing 10, the 10 factorial 10, successively by the required number of which the IGP is to be calculated. So divide it by 2 successively. So 2 will go how many times? 2 will go 5 times. Ignore the remainder, because please note, in case of successive division, we don't pay attention to the remainder. We only take the quotient in the next step, quotient in the next step. So it will go 5 times. Then again 5 divided by 2 will go 2 times. 2 divided by 2 will go 1 time, and that's it. We cannot divide it any further. We'll stop our process. I cannot divide any further, we'll stop the process. Now please note, what is this phi? Phi is nothing but number of single 2's. This phi. Now what is this 2's? This is number of 2's hidden in 4's. So you can see that it was 2 only. And what is this 1? This is nothing but number of 2's hidden in 8's. So there is 1 2 hidden in 8, because in 10 factorial you have only 1 8, 2 cube. Number of 2's hidden in 4's, 2. Number of single 2's, 5. And my answer will be sum of these quotients, which is 8 again. Now if you understand this process and the application of successive division in IGP problems, now you can extend it to any large factorial also. For example, consider this large number. If I ask you what will be IGP of 7 in, let's say, 300 factorial. So what I need to do here, you need to successively divide 300 by 7, that's it. Until you can divide no further. So for example, 7 will go how many times here? 42 times. Some remainder, but ignore the remainder every time. 42 divided by 7, it will go 6 times. Now 6 divided by 7, no division is possible, we will stop the process. And hence IGP of 7 in 300 factorial is going to be 42 plus 6, which is nothing but 48. So we'll get our answer in a matter of few seconds now, once we start using successive division for our problems in IGP. One more, if I want to find IGP of, let's say, 11 in 1000 factorial, let's try this. So you divide successively 1000 by the 11, the IGP of which is required. So 11 will go how many times here? It will be 90 times, because 11 into 90 will be what? It will be 990, 10 is the remainder, ignore the remainder. 11 will go 8 times here, that's it. And 8 divided by 11, no division is possible, we'll stop. And my answer will be nothing but 90 plus 8, which is 98. So this way, sorry, you can find IGP of any number of your choice, right, in any given factorial. The factorial seems to be very large numbers, but still now we have process in place for finding IGP even for pretty large numbers. But however, please note, if I ask you what will be IGP of 6 in 200 factorial. So if I go by this process, so 200 divide by 6 successively will give you what? 33. 33 by 6 will give you 5. No further division possible. So we'll say 33 plus 5, 38 as our answer. However, please note, this answer is going to be wrong. Now let's try to spend some time in understanding why the process didn't work in case of 6 and the process worked really fine in case of 11 or 7 or in case of 2. The reason is simply this: 11, 7 and 2, they were prime numbers. So in case of prime numbers, the process that we have discussed will work. However, 6 is not a prime number, so the process we discussed will not work for a simple reason that, observe, if I ask you what is IGP of 6 in 10 factorial, so 10 factorial is this actually. So in 10 factorial by process, what will be the answer? 10 divided by 6, it will be 1 time. So thus my answer should be 1 only. That you see here also, there is only one 6. However, since 6 is composite, there will be other ways also of deriving 6. For example, you can obtain 6 by this process, 2 into 3, one more 6 is possible, which you are not counting here. 4 into 9, 36, 2 more 6s are possible, which you are not counting here. So that means there will be so many other 6s that will not be counted if you go like this. And hence, please make a note that this method of successive division can be utilized only in case of prime numbers, not in case of composite. So how do we deal with composites? Let me just show it to you with an example. If I want to find IGP of say 12 in 200 factorial. So 12 is also a composite number. Of course, you cannot use that successive division technique. So what we do here is, we understand what is 12 made up of. So 12 is actually made up of 2 square and 3. So 2 2s and 1 3. So ultimately IGP of 12 will be dependent on 2 and 3 only. So let's do one thing. Let's calculate IGP of 2 and 3 in 200 factorial. So how much will it be? 200, 100, 50, 25, successively divide by 2, 12, 6, 3, 1, and when you add them all, 150, 175, 187, 193, 196, 197 is what we get, right? 197. So IGP of 2 in 200 factorial is 197. Similarly, how much will this be? Let's check. It will be 66, 22, 7, 2. That's it. When you add it, 88, 88 and 7 is 95, 95 and 2 is 97. So that means when you prime factorize 200 factorial, the power of 2 is going to be 2 power 197 and power of 3 is going to be 3 power 97 and followed by 5s and 7s and whatever with some powers. We are only interested in 2 and 3 because 12 is made up of 2s and 3s. Now can I write this as 2 power 197, can I write it as 2 to the power 2 whole power 98. 2 into 98 is 196, there will be a separately 2 power 1 outside separate into 3 powers into something 5 power alpha, 7 power beta and so on. This is into, alright, this is into. So on. And this 2 will not help in creating any further 12s because for making 112 you need 2 2s. So how many 2 squares are there? Please note from that representation. So number of 2 squares if you will see. So how many 2 squares are there? 98 are there. And how many 3s are there? 97 are there. So how many 12s will be there? So obviously 12s will be minimum of the 2, which is 97. Now by the way, why is it minimum of the 2? So please consider this example. Let us say your job is of assembling pens. You have 100 caps. You have 250 bodies, pen bodies. So how many pens can you assemble? It will always be lower of the 2, right? You can only assemble 100 pens. Just because you have 250 bodies, you cannot assemble 250 pens because you don't have sufficient number of caps. So always it will be the minimum number that will be limiting my answer. So here the minimum number is 97, hence the answer will be 97. So this is how we can do it for composite numbers. Just one last point and we'll end the video with that. Now sometimes the questions will ask you to find number of zeros, trailing zeros in a given factorial, let's say 100 factorial. So let's try to understand how do we solve for this. So number of zeros, can I say, please understand, number of zeros in any number, trailing zeros, will be equal to number of tens, yes or no? Please think about it. If you have 10 square, that means you'll have 2 zeros at the end, 1 double 0. You have 10 power 5, that means there will be 5 zeros. So number of tens and number of zeros will be equal. Now what is 10 made up of? So 10 is made up of 2 and 5, 2 power 1, 5 power 1. Now in any given factorial, can I say number of 2's is going to be higher and number of 5's is going to be lower, clearly, right, because 2 is more common as compared to 5. And whichever is lower, we just now seen, will be the limiting factor. So hence can I say, let's say in some factorial, number of 2's is x and number of 5's is y. So can I say number of 10's will be y for sure, lower of the two, and number of 5's will be the lower one. Hence can I say number of 10's will be equal to number of 5's. So finally we may say number of zeros in any factorial shall be equal to number of 5's, the prime number 5 in the given factorial. So for example here, how many zeros will be there? This will be number of 5's. Successively divide 100 by 5. 5 will go 20 times, 20 by 5 4 times, and that's it. So 20 plus 4, my answer shall be 24. So number of zeros is same as number of 5's is what we can understand, we can note. Okay. So with this, we have come to the end of the session for today. So I hope you have followed the points that we have discussed, we have taken up here. So in today's, just to recap today's video, what have we covered? We have covered majorly the concept of IGP. Alongside, we have covered successive division. We looked at IGP in case of prime number and composite number separately. Finally, we looked at how do we find number of trailing zeros in any given factorial. Right? So this is a good knowledge part to start our work towards learning more about IGP. So this is like the basic groundwork is done. Now you want to solve more complicated questions, now you can go ahead and try them out. Learning is not complete, of course, I'll agree, it's not 100%, but you're good to go. Once you have watched this video, you would have sufficient idea about what IGP is and how the problems will be, what are the processes like. You'll be able to go ahead with the problem solving. I hope you'll do that. On that note, let me end the video here. Thank you and all the very best.